Hey class, since I have this super duper glasses, I'm gonna try to use them. I'm gonna try to explain um, homeostasis and negative feedback. What is negative feedback? So we have a relatively stable, so the negative feedback is the maintenance of a relatively stable environment. Remember in the lecture, I use an example of rocks. You're putting rocks one on top of another, and it's a relatively stable environment. So the same thing happens in the human body between the systems. So all of the systems tries to maintain that environment. So it's controlled by the organ or by the organ systems, and obviously by the brain, because like if this is the brain, right, blood constantly passes through the brain. So the brain, we'll discuss the brain later. So in the brain, certain regions of the brain, they constantly monitor and regulate what is going on with other systems. So let's look at the example of the homeostasis and the negative feedback. So let's say a temperature, the body temperature. Let's say body temperature is 36.6 and there's a range. Let's say 37.5. And the body tries to maintain this range. Any shift to the right or any shift to the left, this is called deviation, that can lead to unpleasant outcomes. So the body tries to maintain this relatively stable environment because the other systems are also designed to work within this range. So what happens? So the negative feedback maintains conditions within this tight range by reversing any upward or downward shift. So here's a quick analogy. You have a room, storage, and you have a truck, right? And the delivery company tried to bring boxes so you can store them. So the trucks brings boxes and stores them in the room. Now you have to call the delivery company, stop bringing trucks because the room is already full with boxes. There are no more empty spaces, because if the trucks will keep coming, there are no more spaces. So with the homeostasis and negative feedback, we have three players. One is sensor, another control, and another effector. Three players. Sensors, they are sensing the environment. They are looking at any upward or downward shift within this range. That's a set point. Control or control center is the organ or organ systems that maintains this range. For the temperature, it could be the brain and some other organs, but let's think of the brain for now, just because it's a temperature. And the effector is something that will increase or decrease this condition. So if the temperature is going up, sensors detect that you're off of the range, communicates with the control center, with the organ, that will send the command to the effector. And the effector is the organ or the organ systems that will decrease the temperature. So when the temperature climbs above 37.5, sensors detect that, communicate this to control center, to the brain, to bring the temperature down, and the brain will communicate with the effector with other organs or the organ systems to decrease the temperature. Let's say it was 38, to decrease the temperature back within this range that has been set by the system or the organ systems. And the negative feedback, that's a communication. Because when the sensors are sensing the environment that the temperature goes up, talks to the controls needs to communicate back to the sensors, that yes, I'm receiving this information. And the control passes this information to the effectors, but when the effectors decrease in temperature, effectors needs to communicate back to control, yes, I am decreasing temperature but want to stay within this limit. Because if there's no communication and the control asks to decrease the temperature, you can go below 36 to 35 to 34 to 33, and there's a death. The same thing works in opposite. If the temperature is low, we need to increase. They must constantly communicate one with another. If the negative feedback is broken, this is a metabolic disorder. One of the most dangerous metabolic disorder is type 2 diabetes.